In this video, we're going to go ahead and talk about how we're going to evaluate a limit that looks like this. Now, the first step to every limit is you substitute in the value you're looking at. Now, this happens to be as we're approaching x from the right-hand side, but that doesn't matter to us. If we can substitute in 11, we're done. So we're going to substitute in 11, and we're going to get, I don't know what this number is, negative 28 times 11. I don't really care what that number is. The issue I'm going to run into, I can already see it happening, is with the denominator. When I substitute in 11, I'm going to end up getting some negative number. I don't know what it is, 11 times 28, divided by 0. And I know that this is going to be a vertical asymptote. If I were to graph this, I'm going to see a vertical asymptote at 11. Got to draw a lot of little ticks there. Okay, so we're going to have a vertical asymptote. And the trick to this is our graph at vertical asymptotes will always do one of two things. It'll either go up towards infinity or go down towards negative infinity. I just need to figure out which one. Now, the trick to this is I already know my numerator is a negative value. And for me to figure out if this is going to be negative infinity or positive infinity, all I need to know is what's happening to the values in the denominator. If they are positive, then it's going to be a negative divided by a positive, which will result in a negative infinity. And if my if my denominator is negative, then a negative divided by a negative would result in a positive, meaning my answer is positive infinity, because I already know the answer is infinity. So all I need to do now is kind of think to myself, I'm subbing in a number that is slightly larger than 11, just a smidge larger than 11. So when I do that, I could substitute in 11.1, but that's a lot larger than 11. I'm going to just the example, I'm going to sub in 0.001. All right, so 11.001. That's a little bit bigger than 11. Now down here in the denominator, I'm going to do the same thing. I'm going to sub in 11.001 minus 11. Now you'll see for the numerator, it doesn't matter whether I substitute in 11.001 or just 11, because all I know and all I care about is the numerator is a negative number. Now, for the denominator, when I'm subbing in 11.001 minus 11, this number is not accurate. We're not really subbing that in. I pulled that out of thin air. But what I can see is when I sub in a number slightly bigger than 11, 11.001, is it resulting in a positive value or a negative value? Well, it was positive because it was slightly bigger than the number we were subtracting from. So therefore, I know I am dividing a negative number by a positive number. And so a negative number divided by a positive number results in a negative number. So therefore, I know my graph is going to go towards negative infinity. So I have brought in the graph so we can kind of see what's happening here. And we can now see, like, absolutely, I have a vertical asymptote. And as I approach that asymptote from the right-hand side, we can see our y values are absolutely going down towards negative infinity. So that problem right here, where we said, what is the y values doing as x approaches 11 from the right-hand side, we have verified it is negative infinity. Now, similarly, we could have another problem where it's the exact same function, it's the exact same x value, except now we're not approaching it from the right, we're approaching it from the left, where that negative represents a number slightly less than 11. So we would do this the same way. When I'm substituting in a value slightly less than 11, that would be maybe 10.999 over 10.999, whoops, no parenthesis, minus 11. And you can see in our numerator, we're still going to have a negative number up there because it's a negative 28 times 10.999, and negative times a positive makes a negative. And for the denominator now, we're going to say, what is 10.999 minus 11? Well, that would be negative 0.001. And again, that number is not accurate, but it gives us the information we need. All we really need to know is when we sub in a number slightly less than 11, am I going to get a positive number or a negative number? And we can see we have a negative number. So a negative divided by a negative makes a positive. So therefore, the answer is positive infinity. And so you can see This is corroborated by our graph. As we come from the right-hand side, we can see our graph is going toward infinity. Now, a way of making this simpler is to think of it in a way that I describe as big little logic, because the idea here is if you have any number divided by a very, very little number, that is going to be infinity. So therefore, that's what's happening here. We're saying like, look, this inaccurate number down here, it's not really that it's 0.001. What we're really just saying is it is a negative little number. So because it's a negative number, any number could be any number we want. Just divided by something infinitesimally small, something little, that's going to result in something big. That's going to result in something big. And in this case, we're just saying it is a negative divided by a negative, which makes a positive big number, which is infinity. So similarly over here, instead of writing an inaccurate 0.001, we would just simply write this was a positive little number. A negative divided by a positive results in a negative big number, which would be negative infinity. Okay, hope that helps.